Hi guys, in this video we are going to study about chemical reaction engineering, which usually comes for 10 to 12 marks in GATE. The syllabus is divided as follows: kinetics, ideal reactors, non-ideal reactors, non-isothermal reactors, and Thiele modulus. In kinetics we have constant volume reaction system CVRS, variable volume reaction system VVRS, batch CSTR, PFR. For ideal reactors and non-ideal reactors, we are going to study curves, in which we have RDT, F curve, E curve, and impulse and step experiment. Let's get started. And the very first topic is kinetics, and in which we are going to start with constant volume reaction system, which is also called as CVRS, and volume is constant throughout and it occurs in liquid phase. The formula is given as n-1 kT is equal to 1 by Ca to the power n-1 minus 1 by Ca naught to the power n-1 mole per liter 1 minus n, where K is our rate constant given as concentration to the power 1 minus n per minute, n is our order of reaction, T is time, and if in any question concentration is given in some units, we can use it like our concentration is given in unit per mole per unit volume to the power some x value, then we can compare it with concentration to the power n-1, and from there we can calculate our n. For n is equal to 1 by 2, rate is minus dCA by dt, where Ca concentration is equal to Ca naught initial concentration into 1 minus Xa, which is Xa is percentage conversion of A, and rate law is given as minus Ra is equal to K Ca to the power n, which is minus of rate of conversion of A is equal to rate constant into concentration of A to the power n. N cannot be 1, that is cannot be used for first order. This equation cannot be used for first order. And one more point to remember is concentration cannot be negative, means A has converted, if it comes out to be negative, it means A has converted before the given time, indicating 100% conversion. For first order reactor, usually MFR reactors, sometimes a very few question comes on MFR as well, overall conversion can be calculated as Ca naught upon 1 plus tau K to the power n, where n is number of reactors and tau is our time. We would come on it later on. Okay, next is VVRS, variable volume reaction system. Volume changes in it and it is gaseous phase reaction. For second order, like when A gets converted to P, we have this equation, which is 1 plus epsilon A into Xa upon 1 minus Xa plus epsilon A ln 1 minus Xa is equal to K Ca naught T. Epsilon A is our volume expansivity factor, which is calculated as rho y. Rho is sum of coefficient upon individual coefficient, which is equal to coefficient of product minus reactant upon coefficient of required substance. Like for example, if we are given a reaction as this, so this would be to calculate rho, coefficient of product as in P minus coefficient of reactant A upon coefficient of required substance. Like if you have to calculate for A, like how much A is converting, then we have to divide it by A. This would give our rho. And Y is our mole fraction, that is percentage of required substance in feed, like how much A is required in our feed. Now from there we can calculate our epsilon A expansivity factor, which we can put in this equation, and Xa is percentage conversion. These terms would be more clear to you when we would do practice question on it. So as of now, this is like revision notes, and then in next video we are going to do questions which would make it more clear for you guys. So Ca naught, for initial concentration of A, we can calculated by partial pressure by RT, which is equal to Y mole fraction into pressure by RT. Okay, if we have a reaction which is going from AA, small a, capital A, plus BB gives CC, like two products combined to give some third product. For that, we can use this formula. Ca naught dxa by dt gives K Ca naught 1 minus xa into Cb naught, initial concentration of B, minus coefficients of B by A into Ca naught xa. And this now using expansivity factor, we can calculate Ca, which is equal to Ca naught 1 minus xa upon 1 plus epsilon A xa. Rate of reaction is calculated as minus Ra K Ca naught into 1 minus xa upon 1 minus epsilon A xa. And dxa by dt is equal to, like, we can convert this equation into this form, which is equal to K into 1 minus xa into Ca naught into Cb naught upon Ca naught minus B by xa. This is nothing but conversion of this equation, like we have taken Ca naught to the other side and it would give this equation.